this video we will learn how to determine the quantities of optimal bundles given the utility function and the prices of the goods and income of the consumer. The question is, Jenny buys two goods x1 and x2. Her utility function, that is utility deriving from the goods x1 and x2, is being given as is 7 upon 4 x1 plus 3 upon 2 x2 whole raised power 2. Price of good x is 10, price of good y is, or rather price of good x1 is 10, and price of good x2 is being given as 20. Income of Jenny is $100. We have to determine the quantities of x1 and x2 in Jenny's optimal bundle. Okay, so what we are being given, our endeavor will be to maximize the given utility function, that is maximize utility, which is equal to 7 upon 4 x1 plus 3 upon 2 x2 raised power whole square here, subject to the budget constraint such that, okay, price of good x, that is 10 times units of good x, plus price of good y, that is 20 times units of rather price of good x2, which is 20 times units of good x2, and it should be equal to the total income, that is 100. Okay, simple thing. Here it is actually price of good x1 times units of good x1 plus price of good x2 times units of good x2 should be equal to income. Okay, so I have written here this very stuff. Now we know that optimal bundle will occur at a point where marginal rate of substitution between good x1 and x2 is equal to ratio of the prices, that is price of good x1, let's denote it by p1, divided by price of good x2, let's denote it by p2. Okay, now mrs is simply the slope of the indifference curve, and this price ratio denotes the slope of the budget line. Okay, so MRS is simply, as we know, it is simply equal to marginal utility of good x1 upon marginal utility of good x2. Okay, and it should be equal to ratio of the prices p1 upon p2. Now let's calculate the marginal utilities. Marginal utility of good x1 divided by marginal utility of good x2 will be equal to, so marginal utility of good x1 is simply the partial derivative of utility function with respect to good x1 divided by mux, rather mu2 is the partial derivative of utility function with respect to good x2. Okay, and let's calculate it here, taking partial of this utility function with respect to good x1 first. First we apply the power function rule, 2 becomes coefficient, so we have twice 7 divided by 4 x1 plus 3 upon 2 x2, and by power function rule, exponent becomes coefficient and exponent is subtracted by 1, that means 2 minus 1 is 1, and then we apply chain rule and internally differentiate with respect to x1. Derivative of x1 is 1, so we multiply it with 7 upon 4, that is 7 upon 4. Simple thing, we are applying two rules here. First, power function rule, then we multiply the derivative which is inside the parenthesis of x1. Okay, symmetrically, du upon dx2 means partially differentiating with respect to good x2. Again, applying the power function rule, 2 becomes coefficient, 7 upon 4 x1 plus 3 upon 2 x2, and exponent is subtracted by 1. Then we multiply it by the derivative of the x2 which is in the parenthesis. The derivative of x2 will be 1, so we will be left with 3 upon 2. Okay, so what we got here, and here we can actually solve this. So this gets cancelled, this 2 gets cancelled, and this all stuff gets cancelled. So mu1 upon mu2 comes out to be 7 upon 4 times transposing, it will get reciprocated and multiplied. Okay, so we will get 2 1s are 2 2s are 4, so we will get here 7 divided by 6. Okay, and it is actually our MRS. This is our MRS, and it is actually the slope of indifference curve. I will draw this indifference curve here. Then what is price ratio? P1 upon P2, which is being given us is 10 divided by 20, which comes out to be 1 upon 2. Okay, so this denotes the slope of budget line. Okay, here we need to compare the slopes to find out the optimal bundle. And let me draw the simple graph here. So we have x1 on the horizontal axis, x2 on the vertical axis. Here you can see, and obviously, and let me first to draw the budget line. This is our budget line. Let us say this is our budget line. Okay, so let me redraw it here. Let us say this is our budget line. Okay, now its interceptors, if we solve this, and we can find out the interceptors here. So this will come out to be, if we divide it both sides by 10, so we will get x1 plus twice x2 is equal to 100. Okay, when x1 is equal to 0 implies x2, rather it is 10, x2 will come out to be 5, and when x2 is equal to 0, x1 will come out to be 10. So here we have 10, here we have 5, its intercept. Okay, this is the slope of budget line, and here you can see, and actually this is MRS hour, and here you can visualize that MRS, the slope of the indifference curve is greater than the slope of the budget line. Okay, the slope of budget line, so MRS is 7 upon 6 is greater than 1 upon 2, obviously. Now if I want to draw the indifference curve, and here the indifference curve will be a linear one. Okay, you can check it out by setting this utility function equal to some utility and solve for x1 and x2. You will get a linear budget, rather linear indifference curve. So MRS, that is the slope of the indifference curve, is greater than the slope of budget line. That means our indifference curve will be steeper. Okay, so one can be, let us say this is one indifference curve. Okay, similarly we want to reach to the highest possible indifference curve with the given budget line. Okay, we can move on like this. This point will also not be our optimal point. Okay, we will try to reach the highest possible indifference curve like this, and finally when we reach a point where it intersects the budget line at the corner, we get the optimal bundle. Okay, in this case, and here we have seen that we will get a corner solution. That means consumer will, the optimal bundle will be, that means x1 star x2 star will be equal to, consumer will consume 10 units of good x1 and 0 units of good x2. Okay, so with the given budget line, as we know, let us say this is IC1, this is IC2, this is IC3, and this is IC4. Okay, this cannot be our uh, you know uh, any point on this IC1 cannot be our optimal bundle, because some income will be unspent, and we will try to reach to the highest possible indifference curve in such a way that our indifference curve cuts the budget line at the horizontal interceptor. By the simple logic, since this is steeper, since the indifference curve is steeper, it will cut the budget line at the horizontal axis. If it was flatter than the budget line, then it would have cut the budget line at the vertical axis. So in this case, our optimal bundle or optimal consumption bundle will be at a point when our indifference curve cuts the budget line at the horizontal axis. That means we consume all units of good x1 and 0 units of good x2. Okay, so if I write it here in this case, so we will consume x1 will be equal to 10 units, and x2 will be equal to 0 units. and we got here the corner solution. Corner. I hope I make myself clear in this video. Thank you.